Let's examine my paper that I gave in this October-November series. Paper 2. No, I mean variant 2 of obviously. Okay, variant 2. I gave variant 2. And funny story. No. I think that's for when I'm doing paper 2. Skip that and let's start by this awful of a cubic graph. B1 for the correct shape with the distinct minimum in fourth quadrant and distinct maximum in the first quadrant. No turning over at endpoints, suggesting further stationary points. 1, 2.5 and 5 on the x-axis are stated. Independent mark, critical value seen correctly. No contradiction and no other. What? For 25 marked correctly on the y-axis or stated with no contradiction, independent mark. Yeah, it's a little, just a tiny bit wrong. I could have gone for a bit more lenient approach for this. Okay, so anyways, to do this, I plugged in 0 for all, and if we see 1 negative 5 is 25 for the y, and for the intercepts I just set them to 0 and did it by scanning. Okay, then hence solve the inequality this. Now as the method I did in the first paper, I didn't know how to do this actually. No, wait, I'm stupid. Yeah, you see this shading bit, I did this. Yeah, so this is how you get this mark final. So you make this and then you shade the parts which is less than 0. I think you cannot see my pen. Okay, if you, yeah, like this. So parts where it's 0, I just have the interval where it's 0. I know this will shoot off to negative, so that's why it's this. And I prefer x being in the quote-unquote middle of all. Now we get to disgusting territory. Okay, so I will go through the working. That's why I have it in voice. Okay, so the first step is this. You guys can read it, pause the video. Okay, done. And first we plug in negative 2. Nice. Then we plug in negative 1. Okay, I do not know why I went with the marking scheme approach. I could have done a different thing where I did synthetic division, but I don't know, I had a vision, I guess. Then did some what do you call simultaneous equation to get a is equals to 7 and b is equals to 14. Okay, you guys can see the working for yourselves here. I got b1 b2 for this, then m1 to solve there, and 2 marks thanks to this m1 and 8. I don't know why did you have this a1 here. I think that's how they are taught. Show that the equation has 0 roots, and I got m1 and a0 seen or implied for the quadratic. What do you mean? I think this is to no. Oh, I didn't see the remaining. Sorry. Yeah, I showed that it is only this. No real solutions. This is less than 0. So meaning x is the only solution. Full marks. Yeah, you guys can see the whole solution. Then we have sum to infinity and 1, 2, 3, 4, all 4 marks. Let's go through it. So we have a plus ar is equals to 9. Okay, first 2 terms, and the sum to infinity meaning a 1 minus r is equals to 25. We have this a is equals to a no, a is equals to 9, 1 plus r. Okay, 9 over 1 plus r. We plug this into here, which for it we get this stuff. Okay, this a is up here, we multiply it by 1 over and 25. The denominator is solved for, and we just flip the thingies, then we move it there, move the 1 over there, we do some shenanigans. Okay, fix it, and then we take the square root and we find plus or minus 4 or 5 or 0.8 if you have a calculator installed in your brain. Okay, and then we have ooh what happened here? What happened here? Oh, I did it wrong. Oh no. It was supposed to be a is equals to 9 over 9, 5. 1, 1. A is equals to 5. Yeah, it was like 5 over 9 multiplied on both sides. You know, it's kind of sad seeing your marks be lost. Okay, pause the video, analyze this part quickly. Okay, I'll just skim through it, explain where I went wrong and how the working works if it's too ugly, you know. Then for A, we have two B's. Show that can be written in form. This is just simple completing the square. You all know it. Okay, let's pause the video. I did this. I factored out a 2, then added a term and subtracted a term and fixed this bit here. You can see the working. Then I equated, quote unquote, something. I do not know what I did. Oh no, I found the value of b I need to do, and then I got this answer, thank god. The stationary points on the curve, this there's only one stationary point, which is this. If you plug in negative 5 over no, it's just from this negative this and it's normal this, and then f of x is such that greater than equals to p, inverse exists, the least value of p, and my answer for negative 5 over 4 is correct. All 4 are correct. What I did, find the inverse of x, and that's the range, which is the domain of f inverse. Some sneaky I got all 5 points, for a terrible looking graph. Oh god, y is equals to f, and this is y is equals to negative x. 1 mark is for f of x, 1 mark is for inverse of x, 1 mark is for x is equals to what? Oh yeah, it's kind of like a quadrant, like this parabola. So it's a parabola and a lying parabola. I graphed this. Okay, and then I had this negative 1 over 8 also in here somehow, and I do not know why I needed them, but negative 1 is what I needed. Yep, you can see my working over here. You can pause it and see. I like how they scan the pages. It's like very clean. They have this black dot over here, and you do not write margin, not over here. Ooh, 3 marks. Okay, write this in as a single base log. So marking scheme, I do not know what's going on. Holy. So what I did was I put 5 into the power, I put 4 into the power, and I put 3 as 10 to the 3, because you know LG in the exam means log base 10, so this would obviously cancel out. So this, then 80 to 5, 4 and 3. Now this was 8, this multiplied them together. Okay, b to the 4, b to the negative 4, you can think of that. 10 to the 3, 10 to the negative 3, you can think of that. And on the bottom, then I did some expansion of this, and boom, I got the answer. And you can have it in like 5 different ways, you know. Solve the equation this. Now b1 m0 a0 a0 x p. Something tells me I am wrong. Ooh. Quote unquote correct equation. A0 if rejected or crossed out. What? I found only one solution. Okay, let's solve it together and again. Okay, log 5 of x plus 1 minus log of x plus 1 5 is equal to 0. I wrote them as bases. I cross multiplied them together on all sides. So this is square, square, and we put this onto the other side and we take the square root. Here's my mistake. The side I did not put a plus minus, you know. So here on this step, what you do is, so we have square root of natural log of x plus 1 whole squared. So this square is cancelled out, is equals to, we do the same work but it has plus minus natural log of 5 whole squared square root. This is cancelled out. So this is natural log of x plus 1 is equals to plus minus natural log of 5, and we on the same very step we exponentiate on both sides. So this is e to the plus minus log 5. Now I will branch off x plus 1 is equal to e log 5. E log 5 cancels out. X plus 1 is equal to 5. X is equal to 4. Nice and good. X plus 1 is equal to e log negative 5. Log cancel. You can think of this as e to the log 5 and then power to the negative 1. Power is multiplied, so you can have this. X plus 1 is equal to negative and 1 over 5, and x is equals to negative 4 over 5. Yeah, negative 4 over 5 by 1 minus 1 over 5 minus 1 minus 5 negative 4. Nice, done. Yeah, it was my mistake of not having plus minus. See, even if you are good at maths, you are still going to fail in the exam. That's my wisdom of the day for you guys. You see, there's some, yeah, it has my method, but this plus minus, I did not add that. I hate myself. So you solve for the quadratic, then what do we do? Yeah, we then find this. Okay, 1 2 3 4 5 6 scene, 1 2 3 4 5 and a scene tag. Why is there a scene tag? Okay, so we need to solve this equation. Okay, so we solve for the quadratic. Easy, nice and done. Okay, obtain any two values. Now we set it equals to negative 5 and positive 5. If we set it to negative 5, we have 2 x squared plus x minus 10 is equals to negative 5. No. What? Wait, yeah. Yeah, one case is having it 5. Okay, if this is positive, then we have this positive also. So we set it, so we did that, all that, bloat, and boom. Then we have the case that this entire inside is negative. So since this entire inside is negative, we open the absolute, this is negative, and to fix that we have negative over here instead. Okay, I did not do the square method. I would get a quartic, and you cannot solve a quartic in this stage or ever, simply who remembers how to get the quartic formula, let alone make the quartic formula. I hate this question. Point A, B, C has this funny gradient. I did this one little mistake. I put a negative over here. And that negative is very costly because I saw it being later. Okay, there's like a bunch of scene. I get it. You have seen this like 4 times already, 6 times. Yeah, I did this like multiple times, but here's the most embarrassing thing. I put the wrong question code. Yeah, this is 7B, guys. Okay, this is 7B. Look what I got. Look what I wrote. 9B. Now, you cannot argue that you just wrote 7 with a hairstyle. No, it has a big mouth. So that's obviously got to be 9. And you can see they have seen every bit of this page. Okay, from top to down. But I have the wrong question. Yep. Well, anyways, I should probably explain this question. Obviously, I graph this with schizophrenia. Okay, and find that the distances must lie onto a centroid point over here. This centroid point is the centroid of these two. This center we have found to be the center of, I think it was AC. I think it was AC. I do not know. The center is center of something, and allow for 2, 7, or 9, 6, meaning either this or either this. Yeah, you can like find the center like this or something. Then we know this distance would be the same for these two, and so we found the radius of the circle, which is 50, and then we plug in everything and boom, 50, like so. I would have gotten these 4 marks if I hadn't written the wrong question quote for it. Let's enough crying. Let's go back and see the rest. Sketch the graph of this. State the intercepts with axis and equation of each asymptote. Now I did the asymptote stuff. The very green. You are going good when you have the green check marks. That's lovely. But when you have a benefit of doubt, it's like you have been saved or something. Okay, now I know a logarithm dies out later, but I made it probably sooner. That's why they gave me BOD, benefit of doubt. Anyways, here's my working for benefit of doubt. I think there are different examiners who checked my paper, like parts of my paper. One seen like a billion times, and one seen like it green ticks. Okay, here's a messy one. Okay, so 11 whopping marks for the first part. So I will go through the working. If you guys want, I can redo this paper for you guys. A curve is such that y is equal to f that the curve y is equal to f of x is such that the second derivative is this equation. The curve has a gradient 2 over 3 at a point 2, 2, meaning the value of the first derivative at x is equal to 2 is 2 over 3. Okay, and the value of the original function at x is equal to 2 is 2. We have 3 datas. Okay, 3 data we are given, and we need to find the point coordinates of the stationary point on the curve. So let's go. And the marking scheme is embarrassingly small. Okay, so first we find the we integrate this. I used u substitution, and we find that f prime is equals to this thingy. We get m1 and 8 m1 a1 m1 a1 plus c. Okay, I like to add a massive plus c. I did a small plus c, sorry. Then we plugged in 2 and solved for c. Now I have written capital C out of nowhere, which is 1 m1 a1 for seen or implied. Next, what I do is do the same work. They use D also. They use D also. What? So yeah, you can see I have capital D here, and I first integrate m1 a1 and then solve for D m1 a1, and then finally when I have f of x solved for, I set it to 0 immediately. I set it to 0 and solve for the intercept. I set it to 0. I solve for when it is 0, which is x is equal to negative 2, and we plug this f x is equal to negative 2 back into f of x to find this, and we find the last mark a1 stationary point at negative 2, 0. You guys can rewind the video if you want to see it again. And you have seen this upper portion of the page 3 times. Very generous of them. Determine the nature of the stationary point. Now this is just a laughing stock. They even use the therefore symbol in the marking scheme. Wow. So we find the second, we already have the second derivative. Okay, and this plug in negative 2, which we found with hard work for that 11 marks, just for the remaining 12th mark. We had everything. That's not that one thing. Next is this, and this morning I was like sleepy, like you wake up for like near Fajr, you're waiting for Fajr and stuff. Someone asked me this question. I was wrong on so many levels and I couldn't do it, and I got all 5 marks. A1, M1, 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 A1, done. Okay, so how do we do it? We have this going on. We expand this sine squared plus cosine squared plus 2 sine cosine plus sine squared cosine plus cosine squared minus 2 sine cosine. This is gone. Okay, we cut the sine cosine, 2 sine cosine. We are left with 2 sine squared plus 2 cosine squared, and this 2 sine is equals to 2. Okay, let's divide the question by 1 and 2, done. That's how we get the second step in the marking scheme. Here, Then we integrate from pi over 2 to 3 pi over 2, and this is just a constant. So we basically minus it. Okay, so all that just for a 2. And we get the answer k is equals to 2 k pi. Nice. Solve the equation. They've seen this 4 times and they have laughed at it 4 times because I cannot solve it for all those 4 times. Yes, I never found the answer to this question, and even when I was doing it like a week ago, I could not solve it and others helped me to understand it. Now, this stems from my misunderstanding of the thingy, and I still did that very same mistake when reattempting this question. Okay, when doing this. So, apart from this mayhem, I will solve this question now. So we have n minus 4 n plus 1 c5. So we have n minus 4 n plus 1 factorial all over 5 factorial n plus 1 minus 5 factorial, and this is equals to n plus 2 factorial 7 factorial and n plus 2 minus 7 factorial. Now I can simplify this on the screen. You guys can just write the next step. Okay, n plus 2 factorial is same as n plus 2 n plus 1 factorial. 5 factorial 7 factorial is same as 7 times 6 times 5 factorial. Now here's why I was wrong. I did this simplification step. Yes, it's the negative factorial that caught me. Okay, I thought negative 1 factorial is not this. It is n. Yeah, this might seem stupid as to why I made the mistake. So do not repeat that. I'll show you the solution instead of laughing at myself. So n plus 1 minus 5 is n minus 4 prime. N plus 2 minus 7 is equals to n negative 5 prime, and n minus 4 prime consists of n minus 5 prime. So this is n minus 4 n minus 5 prime. Okay, this is the second step in your answer sheet, and you cancel out this with this, this with this, this with this, and this with this. I know. So this is 7 times 1 is equals to n plus 2 over 46. N is equals to 46 minus hold up, wait a minute, something ain't right. Yeah, okay, I'm not right. This is 42. 42 minus 2 is equal to 40, and that is your answer right here. Okay, so for anyone who can't read this, thank God. Okay, please do not read it. Then we go to here and continue on with our working. And 12, a curve has equation blah blah blah. Find this blah blah blah. Find the derivative. So the first step to do this is derivative. Why is this cancelled out? Yeah, I think this is cancelled out. Undefined blah blah blah. I did it wrong. So how do you do it? This is you use tons of power rules and chain rules, quotient rule. You use every rule that there is in the book. So we get x plus x minus 2 e to the x squared minus e to the x squared times 1. Okay, x minus 2 squared. Okay, how do we do this? Well, this is, I write it like this: f prime times g plus f times g prime. Okay, the outsides are prime. Okay, and a minus in the middle. Okay, and we simplify by plugging in 0. If we plug in 0, this is 1, this is 1, this is 0, this is 0. No. Yeah, this entire fraction is 0 because of this and this. We have this lonely 1 here, then this is negative 2 squared, which is 4, and this is the final answer. I scored 2 marks on this, and I do not know how. We know dy dx, and we have a time variable. I do not know how did I do this, and what do I mean by dy dx, dx dt, dy dt. Okay, so what I did was, we have negative 1 over 4. The derivative at x is equals to 0 is negative 1 over 4, and y increments 0.5. Okay, so we have 0.5 and x is just normal dx, your usual. I use the partial symbol for fun, but anyways, so when x is equal to 0, you do this. For these questions, how do you do it? Please forgive my Discord messages. Okay, so when you have like y changes, like something changes, what you do is find dy dx at x value, then you do dy over dx, and the question, okay, let's just use delta y delta x, and this delta y delta x value is dependent on the question that is the value the question provides you with. Okay, same as the last video we did this. Okay, the trig graph thingy, blah blah blah. The trig values that you're given, it's the same as how you're giving in 4024. Ooh, oh no, oh. It's like seeing like a car accident, but instead of an accident of a car, it's the accident of your own working. Where on earth did I introduce that over sine squared? Okay, could does it hate me not putting theta? Okay, how do we do this? You get y is equal to this, c not implied, and sine theta is equal to 2 minus x over 3. I did not get 2 minus x over 3 whatsoever, and I wonder why. Let's redo this question because I did a very big blunder over here. For this interval of x, it is given that x is equal to negative 2 over 2 minus 3 sine of theta, and y is equal to 3 cosine squared of theta. Find y in terms of x. Now, instead of me doing all this, we didn't do it correctly either, because this step is theta in terms of theta and y. We separated nothing. Okay, it is my delusion of using cosine and sine normally. So that's why the entire question is cross cross cross. So how do you do this actually? Okay, so we want to find y in terms of x. We need to relate y and x together. This is in terms of theta, and we can solve for theta by, no, we can somehow get sine theta by itself. Okay, since this expands to y is equals to 3 cosine square theta over sine square theta, you can get somehow sine in here and plug it in here, and cosine squared is 1 minus sine squared, no, cosine 1 minus sine squared theta also. So that is our game plan here. So we have x is equals to 2 minus 3 sine of theta, x minus 2 on both sides, multiplied by negative 3 on both sides. Okay, let me just move this over here, and yes, I'm just using the marking pen, and since it's a negative, we negative on up, and this is 2 minus x over 3 is equal to sine of theta. Now we can plug this into the original equation. We have y is equals to 3 times 1 minus 2 minus x over all over 3, and this fraction squared, all over 2 minus x over 3 squared. Okay, now let's simplify this a little. It's looking way too ugly here. Now this is 3 squared is 9, so we multiply 9 on both sides to cancel out this 3. Okay, so this is y is equals to 3 minus so this 3 and 3 cancel out, so what do we get is 2 minus x squared all over 3 all times 9 all over 2 minus x whole squared still, which is, if we continue, 27 minus 3 times 2 minus x squared, 2 minus x whole squared all over 2 minus x squared. Okay, and we have found y in terms of x somehow or in some way, and we can just leave it like that, or equivalent, or equivalent, or equivalent, whatever way you like. Let's have it in the marking scheme way. So this x squared cancels out, and you get is equals to 27 minus 3 perfect, like so, and this is y. Now let's validate our steps. Let's verify our steps. Okay, I'll be careful and redo this multiplication of 9 slowly and again. 3 minus 3 2 minus x over 3 squared all over 2 minus x over 3 whole squared. So this is 3 2 minus x whole squared all over 9 is equals to minus 3. Multiply this 9 on upside, so this is 27, and you get the same damn step. So there is nothing to worry about. Okay, and if you look at the marking scheme, y is equals to 27, we get the same values together. Yay. I hope you guys like this video, me showing the trash of a paper I did. See, first time this is my doing of the circle question. Yeah, I was doing wild. I was sweating bullets. Sweating bullets upon bullets. I've seen this like a bunch of times, more than you have seen my videos. And bye. Okay, like, subscribe, share, and